Thank you, Camille. Okay, so now we are moving to the Q&A session. I can see that there is already some questions in the chat. Feel free to ask more. Okay, so I don't know who is asking, I cannot see it, but there is a question for, I think it's for Florian, regarding the distance. And the question is, we were wondering how you measure the delta between the wavefront phase and the structure.
We did this using the hexapod, so the motion generator, so we can precisely modify the position of the motion generator. So we fixed the distance, the braking location at 21 meters, and then we fixed the distance of the front face using the positioning of the wave generator. And so this gives a first estimation of the delta value, and then we modified it by considering the actual braking location, so which is not exactly 21 meters, but 21 meters plus or minus a few centimeters, and we determined this using the numerical wave tank.
Okay, and I would like to extend the question regarding this, Florian. How did you do that when the cylinder was moving, to make sure that you were always looking at the same stage of braking and draw your nice decay curve as a function of the body velocity?
So for the moving cases, we use the evolution with delta. So we did so that the impact occurred for the delta, which gives the most important load, and yeah, we choose the velocity of the motion of the cylinder so that it occurs at a good instance. And yeah, one other thing is the impact also occurred during a phase of constant velocity to be sure that the measurements are not polluted with the acceleration of the motor.
Okay, thank you, Florian. Okay, is there any more question? I remember that there was one regarding the definition of the B parameter and what was the variable, and okay, I just replied that B equal U over C, where U is the horizontal feed velocity at the crest, and C is the phase velocity of the crest. So feel free to ask more questions. We still have some time for this. I'm just checking, I can see more questions. No more questions? Okay. So I'll share again my screen to add some words regarding the conclusions.
Sorry, Jean-François, I think
yes.
You have a couple of questions actually.
Okay, I cannot see them.
4 or 5.
Okay, good. Where can I see them? I can only see that of Samuel. Ah, okay, I can see others, but sorry, I'm just trying to see the questions. I have a question. I don't know who asked it, but we try to answer. How have you gone down to comparing impact of larger hydrolos on sizing the structure of the floater? You mean, did we look at the load at full scales, right? Is it what you ask? Not sure. Okay. So here we stay at model scales. We were more interested in relative loads and impacts of the distance between breaking points and the cylinder, effects of the tilt and motions. We are not looking too much into the actual loads at full scales here, but of course that's of interest for us as well. But I'm not sure I'm answering the question, so I'm just trying to open this question panel. What about floater with flat panel? I can see these questions. Yes, so all the work we did regarding engineering formula for loads on the offshore structure were dedicated to cylinders. Part of the project result that we did not present today could be extended to this kind of problem. But for most of the project results, it is more designed for cylindrical structures or floater made of cylinders or bottom fixed structure made of cylinders, meaning that we are still addressing quite a wide range of technological solutions. But you're right, for this particular case of, let's say, flat panel barges, we cannot like run what we have done in the open FOWT or Diego model directly. It would require more development. Okay. Trying to see what was the gap. Can anyone see the question, or I am the only one being able to see the question? Because I cannot open the window, so I can see only line by line.
I just sent it you in the chat, Jean-François.
Sorry. Okay.
I put you the question in the chat.
Okay, thank you very much. Yes, here I can see. So thank you for the greetings. And the question is, how would the old approach apply to larger cylinders? Cylinders with hydro loads are modeled in open SAS based on diffraction body. Maybe this is a question for Paul. Paul, can you see the question in the chat as well? Paul, can you hear me? I'm not sure. Paul, are you still here? Cannot see here, Paul. I can try to reply. So as okay, Paul, you're here. Good. Go ahead, Paul. I cannot hear you. Can you see the question
okay?
and try to reply? Yes,
no,
that's okay.
I cannot see the question, but it's regarding the variation of the cylinder diameter, right?
Yeah, I can repeat it. How would the old approach apply to larger cylinder and cylinders which hydro loads are modeled in open FAST based on diffraction body?
Well, actually, the approach is based on the FOWT assumption. We do not account for the diffraction effect, so we can apply this methodology for any type of diameter. So here, yes, you will have bigger hydrodynamic loads than what we've done, but the slamming coefficient rates can directly depend on the radius of the cylinder, and then we can directly extend the approach for larger structures.
And just to mention that we did some CFD simulations and looked into the effect of the cylinders on the load as well in a paper by Marc Battier that you can find in Cost Engineering. It was just published 1 week ago, something like this. Okay, another question which is any plan for inclined horizontal cylinders? So we explore a range of inclined cylinders from -15 to 15 degrees. we could look at that, and horizontal cylinders as well. It was not in the plan of the project. We are now thinking about what to do next. I will say a few words about that later. And possibly we could try to explore this kind of configuration as well. Okay. This is a good question for Florian. How the hammer test was done? Is it cylinder inside water to account for added mass?
So we did the hammer test with an instrumented hammer, so we could measure the load applied on the mock-up. And yes, we were in the final position, so in the position of the experiments. So actually, we had water during the hammer test up to the top of the fourth section. So we do account for the added mass during the hammer test, even though depending on the impacting waves, the added mass will change. And yeah, for sure, we don't account for it during the hammer test.
Thank you, Florian. Feel free to ask more precision if you need in the questions. Okay, it's an extension of the previous question. So the question is, have you gone down to comparing impact of larger hydro loads on sizing the structure of the floater? Okay, and then there is a precision, and it means apply loads on the structural model, check stresses, and see if thicker plates, heavier steel is needed. So that's a very good question, and a fair question. So we basically stop on the fluid structure interaction and went not into too much discussion regarding the structural response of regarding slamming loads. Maybe just to mention that we made a deployment with the Cercel team of accelerometers on the Z-Flyros floating offshore wind turbine in Norway. So we did some structural analysis of the tower response to different loadings, including waves and aerodynamic loads. But we are not able to really distinguish the loads due to breaking waves. But that's a very good question, and we should look further into the structural response in another project. Okay, so next question is again for Paul, and you already answered part of it, but I'll ask it again. Did you study the influence of the column diameter on the loads?
No, we did not study it because it was not done in the experimental campaign nor in the CFD. Well, in the CFD, it has been done for one configuration. It was for plunging breaking wave when the request was already overturned, but it has not been done with the similarity model.
Okay, alors. The question for
just to complete. However, actually, the slamming formulation is directly proportional to the radius, so you can directly assess it by just multiplying the radius of your cylinder.
I guess the question was, is there a change of physics in the load when you change the size of cylinder? Right?
Well, yeah, and actually we can expect maybe for larger structures that the diffraction would be bigger. And so this is an issue we had, for instance, for speeding breakers, that the diffraction effects are significant. And so that's why the slamming load formulation is quite conservative for speeding breakers. And so with larger structures, diffraction effect can be bigger.
Yeah. There is a question for Camille and Christophe. Does the addition of such hybrid loads, a very big step in the load in floating offshore wind turbine simulation, raise any issue regarding numerical stability?
Maybe I can start the answer. On the rigid body motions, we haven't seen any instability coming from adding these loads. But as Jean-François said before, we didn't went until the floater deformation level. So we cannot be sure that there is no stability issue when we consider the floater flexibility. So as long as it is rigid, it's fine in terms of stability.
Okay. And maybe another question for you, Christophe. Do you expect this additional load to have any significant impact on the floater global rigid body motion, like extreme tilt, for instance? Or those are only a concern for structural column design?
My feeling is that it will mostly affect the structural design, and the loads will be probably too short to excite any rigid body motions, except maybe for TLPs that can be quite stiff. Yeah, that's just my feeling.
Okay, thank you, Christophe. Another question regarding the structure. Have you looked into the impact of this load on the structures? How could one translate these punctual loads from open FAST into stresses on the structure? Maybe Christophe, you are also the best one to reply.
If I understand well, it's how we will move from loads applied on beams until
Yes.
pressures. I don't know exactly. In fact, there were pressure measurements that could be used, but I think it's a bit challenging to have a pressure distribution. I don't know, Paul, if you have any idea about that, or Florian.
No, not really.
So I think we need a dedicated campaign to look at the pressure distribution if we want to move to something that is not a beam.
Yeah, okay. Thank you. Okay, let me see. I see that Camille cannot answer because his micro is shut down by the organizer that is supposed to be me, but I don't know how to open it. So
now it's good.
This. Okay. Do you want to add something, Camille, maybe?
No, just maybe I can complement for the open FAST. We hadn't any numerical instabilities neither. So
okay,
that's about it.
Thank you. Okay, I think I went through all the questions. Thank you very much for your contribution and to the discussion. You can still pause them. I'm just checking if. Yes, I think if Melusine is transferring all the questions to the chat, we already answered all the questions. Okay, just some wrap-up words very quickly. Let me share my screen. Sorry, Matthias, I'm just trying to find the screen sharing button that for some reason disappeared. Okay, let's do this. I don't know which screen you are seeing.
Yeah,
can you see the presentation or another screen?
The presentation.
No presentation?
Yeah, we can see the wrap-up words.
Oh, okay, very good. Okay, so very quickly, as you saw, we came up with some interesting results regarding the attitude of floating offshore wind turbine in high seas, and also the effect of this floater dynamics on the loads based on the wave tank results. Then we use also the wave tank results and some other theoretical results to derive this full methodology to assess the loads through FOWT coupled models. So as you see, this is still an ongoing work, and for each of the steps and each of the scientific results that we presented, there are many open questions that actually you also address in the chat that we should work on together to really make an even more reliable method. And I would say that also the main drawback of the work right now is that it's a very appealing theoretical framework that we have set up. We did some very nice validation with wave tank experiment regarding very detailed loads and with very fine description of the waves, but still we are lacking a statistical validation of the full approach. So I would say that maybe one of the main important steps now is to really compare or apply the results to real or realistic sea state conditions with irregular waves, irregular breaking waves, possibly 3D configurations, to really go into the validation of the full method and also of some of the steps of the method, especially regarding the linear to nonlinear relations that we use for the methods. Okay, so we are thinking of what to do next regarding the improvement of this project, and we hope to be able to start a new project soon. Okay, so I would like also to thank the scientific team. Hope I've forgotten no one, because it's really a team effort, and we were able to show only part of the results because it's supposed to be a short webinar. And so there was other contribution from other colleagues that are shown here to the project. And also I would like to thank Mélie Zingaya from France Energy Marine for the organization of the webinar. And I think that's it. I would like to thank all the participants for their contribution to the questions and just also listening to the results of the project. And I guess if there is no more question, we can close the meeting now.